So these guides, along with good process, all of a sudden, high performance is easy.
You know, this rethink towards net zero is rethinking a lot of the traditional building enclosure assemblies and building them better.
I get excited, but I also get depressed. I'm depressed because I'm old. And if I was younger, I would embrace this opportunity for this change. I see the young builders, and to me, I get excited for them.
James.
How are you doing, Gray?
Good.
All right. We're at the BCIT High Performance Lab, and what do we have here, Graham?
Yeah, so James, this is LEEP wall number 2, which is our low permeance exterior insulation that is also detailed as an air barrier. So we call this low permeable airtight exterior insulation.
Interesting.
Okay, so the way this approach works is our foam plastic insulation, or low permeance foam plastic insulation, is detailed on a traditional 2x6 frame wall as your air and water resistant barrier. So for an exterior insulation to be used as an air and water resistant barrier, it has to meet a bunch of test standards. So you have to basically test the insulation, the accessories to be air and water tight reliably over the life of a building.
So you're not making this up, it's just a tested assembly.
That's right.
Yeah.
So there are a couple manufacturers in Canada that manufacture rigid foam insulation and tapes and accessories and details to provide this wall assembly.
ICF foundation, 2x6 framing, exterior insulation, rain screen cladding, vented attic. There you go.
So what's unique about we got foam plastic insulation on this wall, right? So we've got, what do we got? Extruded polystyrene?
That's correct.
Yeah, and our extruded polystyrene in this wall is our air, vapor, and water control layer.
It's all in one layer, that's correct.
Yeah, the thickness of that.
Yeah. Yeah, provided I have that thickness
Yeah.
in that wall assembly, which I'm representing that I'm doing that.
So in this particular wall, we've got 4 inches on the outside, so we got R20.
Yep.
And we got about R20 in our bat wall here, right?
That's right.
Yeah. So as a builder, you know, I've seen a lot of walls driving around town that only have 1 or 2 inches of insulation. What are you typically doing there?
With 1 or 2 inches of insulation on the outside,
Yeah.
I would be scared with this wall assembly.
Yeah. Why is that? Why would you be scared?
I don't have enough insulation on the outside to maintain the temperature of that sheathing and its relationship with the dew point and the potential for condensation related type moisture. And then I'm really suffering with the ability for this thing to dry out properly.
Yeah, so we got impermeable foam plastic insulation, so XPS, thick amounts of EPS, effaced polyiso insulation. So we got an impermeable exterior insulation.
That's right.
So with impermeable exterior insulation, it's really critical to get that ratio of exterior insulation to cavity insulation right, and manage that vapor control, right? So if we look at this assembly here, and we got bad insulation, we got the foam insulation on the outside, we want to get a high enough ratio of the foam insulation so we can, on the inside, throttle back on putting a vapor barrier, right?
Right. There's no vapor barrier here. So if I don't have enough insulation on the outside,
Yeah.
I am going to get condensation in my plywood.
That's right. So
And so that can lead to extended wetting and issues. I want to reduce that, so this is why I put 2 layers on the outside to represent that it's a wall assembly that you want to put enough insulation on the outside, because even though it can dry inboard, the amount of wetting is excessive.
That's right.
Potentially.
Yeah, so the whole trick with this type of assembly is you put enough exterior insulation, and that ratio of exterior insulation depends on your climate, the indoor conditions, right? So when you put impermeable insulation on the outside, we don't want a vapor barrier on the inside because we don't want moisture to get trapped, especially in wood framing, or especially initially, built or initially wet construction, or water that gets in service, right? So we're managing our air and water on the surface here. If air leaks in here and condenses in this wall, we got an issue, so we need some insulation. And we also be very careful with water management, window details and such. So we've got, 4 inches in this case here. If we had less insulation, the risk is with no vapor control on the inside, or light vapor control, maybe a paint, then we might have too much vapor diffusing through, and we might get condensation, or at least elevated humidity that the moisture in the wood would be such that we can get mold growth, right?
Yeah.
So we need enough insulation to balance the outdoor temperature, but also the indoor humidity. And the whole trick with this assembly is get enough exterior insulation, so ideally you could actually remove the vapor retarder.
Yeah, and you know, as a builder, and I think about this as I build it, and I think about other LEEP walls, is if I'm going to do this, I'm looking, well, maybe I want to have some kind of control measure here if I'm not sure. You know, that's what I think when I'm building this. Is like, is it enough insulation?
Yeah.
And so other LEEP walls like LEEP Wall 3, where you have that ability to manage moisture at this level,
Yeah.
might be something to think about, or make sure you have enough on the outside. But those are the considerations for this wall type. And when I was putting this together, that's what was going through my mind. It's like, how much do I put on the outside? What if I don't put enough?
Yeah.
Will I have a problem?
Yeah, so if, this wall will work. This
Yeah, of
wall,
course.
with enough exterior insulation and the way this is being detailed and using a tested system that the tape is going to be flexible,
That's right.
then it will work as an air and water control there. Now, there's a lot of foam plastic insulation that hasn't gone through that testing. A lot of manufacturers across Canada that make EPS, polyiso, and even some XPS that hasn't gone through that testing. And that's why we have wall number 3, where we have that house wrap behind, and we have our air and water control at the sheathing, at the house wrap, and then we have drainage provision, so if water did get in behind. But it also provides a more traditional approach, right? This is very different, to pulling, the air and water control to the proprietary system, right?
Yeah, and where you build is going to matter, in my opinion.
Yeah.
As someone that is out there and cutting my hands sometimes when I make a boo-boo, but with somebody that's out there is, in my mind, I want to protect my structure.
Yep.
But if I'm somewhere that's cold and dry or just plain dry,
Yeah.
I'll
It's
see
easy. Yeah.
no issue.
And that's why
Just get the right ratio.
Yeah, and that's why we see a lot of foam plastic on the outside in the prairies, where they are
Sure.
doing this with thinner amounts. And what's really different here is typically with getting to these higher R values with net zero ready, we're talking 4, 5, 6, maybe 8 inches sometimes. And the reality is you can't get one thickness of insulation. So you're 2 layers of insulation, right? And so you've got 2 layers of insulation. You're still doing surface air and water control. And then our vapor control is really carefully thought out in this assembly. And that's where the guides go through the ratios, goes through the climate, we walk through, and to make this wall safe, put all the insulation on the outside or the majority.
Yeah, and obviously I read the guides before I went and built all these things here, and these are some of the questions that I had is,
Yeah.
what is the right amount? And I think that becomes pretty clear.
Great.
That you want to have most of it on the outside. And if you build in a drier type climate, that this is a tested wall, it can work.
Yeah.
But be careful if it's a moist environment.
It's good advice. Now, one detail I noticed here, I noticed that you've taped up the foam all the way through, from your ICF all the way up, but this isn't taped here. What's going on here? What are you doing with this membrane in here?
It's a funny, and I'll make a comparison, okay? If you remember that flap, a Tyvek we used to have and showed on other wall assemblies that came over top, it was just your water resistant barrier.
Yeah.
It wasn't taped either, right?
Not part of the air barrier, yep.
Not part of the air barrier. The air barrier on this assembly comes across the insulation to the transfer at the top plates. And that's where the similarities again to a vented attic become similar again.
Yeah.
So a lot of things are similar. The fact that this insulation is serving as my outside layer, you just treat it like it was plywood with Tyvek, and you dress it the same again.
Yeah.
So again, it's another similarity.
Yeah.
The only big difference is you have no moisture barrier on your plywood
Yeah,
substrate.
so I got my air and water resistant barrier transferring through back into the top plate and then across to the attic on the inside.
Yeah,
of the
that's right.
vent.
I mean, we could have a look. You can see that just transfers across.
It's pretty handy there, James,
Seems
having
like-
a roof you could tilt
Well, I
off.
feed it Smarties, but
Yeah.
I mean, you can transfer it across the top.
Yeah.
And there's just a chance to show that.
Now, one thing to note here, we've made the foam air and water tight. Is there any reason we couldn't make the plywood and air barrier first and then just make this tape for water?
Yeah, you could do that.
Yeah. Would that have some
Absolutely.
benefits maybe? Would you simplify this type of detail? You wouldn't need to do this transition. You just have an air barrier transfer through and not worry about.
That can take an approach.
Yeah.
But one of the things that's interesting is, and I caution is, when you're doing this, try to use proprietary systems. Okay, work with the proprietary system.
Yeah.
Learn that system.
Work with the manufacturer.
Work
Yeah.
with the manufacturer, develop expertise in whatever wallet type it is,
Yeah.
Then if you want to make some tweaks and changes, don't start tweaking something that's already tested out of the gate. I don't recommend doing
Yeah,
that.
and it's important to use the tape, the manufacturer's tape, and not use someone else's
Yes,
tape, right?
it's
Yeah.
proprietary system.
Yeah.
That means not proprietary one piece and buy another piece and call that a system.
Yeah.
And the same here with this tape that's on here. This is only not sealed.
Yeah.
Okay, it was just to wrap it up, but so I could open the lid and show you the top.
So what we've got here in this wall assembly here is we got 4 inches of exterior XPS, extruded polystyrene insulation, about R20, and then our backup wall here, which is about R16. So effectively with the cladding attachments and everything else, we're about an R35 wall. So this wall here is around the point of net zero ready for parts of Canada.
50-50 inside, outside.
Yeah, so we got half the insulation on the half the insulation on the outside, and half the insulation on the inside. And so to get to different R values, we just adjust the thickness of insulation. On the mock-up here, we've got 2 layers of insulation because it does create some complexities in how you detail the air barrier with this assembly.
You'd have to bridge through both layers to get an air barrier instead of just simply connecting one.
That's right, it does create some unique challenges. Yeah, so the higher R values is thicker foam, or thinner R values, we use less foam. This wall assembly typically uses extruded polystyrene because that's the type of products that are being generally tested for this application. So if you want to take this approach, you have to reach out to the manufacturer and say, is your insulation tested to be an air and water resistant barrier? If it is, then you can proceed. If it's not, that's why we have wall 3, which we'll talk about in another video. So if we're putting this amount of exterior insulation on this wall system, what it does to the backup walls, we need to rethink the vapor control strategy. Okay, so what we don't want to do is to stick, 4 inches of impermeable insulation on a 2x6 wall with batt and poly, because we already have a vapor barrier in that wall, and we don't want 2 vapor barriers in this assembly, so we can allow at least drying to the inside, because we got impermeable insulation on the outside. So the whole strategy with this wall is if we have thin amounts of insulation, we might use a smart vapor retarder or vapor retarder paint, so we can allow some inward
drying.
And thinner amounts of foam too also allow a bit of drying outwards. 1.5 inches, 2 inches is still around a perm or so, but once we go to like 3, 4, 6 inches, that's pretty impermeable, and therefore we want to open up the inside to facilitate drying. Okay, so the strategy and what's covered in detail in the guide is what's the ratio of insulation you need on the outside to be safe. And so what we've shown here, about 50-50, and as we add more, it becomes even more safe. So one thing you'll notice with this wall here is just we just got batt insulation and then drywall. And there's no polyethylene on the inside to function as our vapor control layer, and we don't have that there to be an air barrier. With this approach too, the air barrier is going to be that foam insulation on the outside. So in wall assembly 2, with our foam plastic as our air and water resistant barrier, this is detailed for managing all of the water and the air tightness of this assembly. So what it means when you look at this, you actually, in theory, don't need to put a house wrap on the backup wall. And if you do, it actually creates some challenges.
Is there special climate that, or more climate-specific application?
Yeah, I mean this will work everywhere across Canada.
Yeah.
The considerations if you're building this when it's wet, you don't want to be putting this insulation over soaking wet wood. You need to dry it out. So that's where a house wrap or something can keep it dry, and then you can be there and keep it dry, and then you put the insulation on. However, you need to be very careful with putting this over wet wood, so you don't trap that moisture in there. And drying.
But does it not dry to the inside?
It can. You got to provide a bit of during construction a bit of heat to dry it out a little faster. So you're gonna make sure the backup wall is dry, but you'll notice there's no potentially no house wrap on this. Okay.
I see that. That's an unusual application.
Yeah, this is different, right?
Or non-typical, I guess you would think.
So because we're relying on the foam and tapes, and the tapes that are part of the system are being tested to be air and watertight, and they stick really well to the insulation. So our water control strategy with this wall is the face of the exterior foam insulation plus tape and flashings and everything else that ties it. Everything is treated to the face.
Right.
So we're treating this as our water resistant barrier, air barrier. And so what that means is all of our laps are on the face. And so you actually end up with a lap that isn't shingled. So this is critical to get, smoothed out and, follow the instructions there so you're not getting fish mouths. Some people will put another layer of tape over top to
Double it up
Double
type?
it up. Yeah.
What about shiplap joints?
Yeah, and so
et cetera?
shiplapping, or in this case, the mock-up shows here a slope joint at the head, but you can also get shiplap joints. Yeah, if we look at this here, so shiplap joints here can help.
Yeah, well,
with
I
the
wouldn't
water
be
management.
concerned about water entry on that joint.
That's right, and even stagger joints if you have 2 layers of insulation.
Sure, yeah.
So our water control layers are our foam, our tapes, our flashing membranes, and integrated flashings. Everything's done on the face. Now, what you also notice about this wall is we also got strapping to hang or to attach our cladding to, and we'll get into that later on. So what that means is you actually need to do all your taping and
Sure.
sealing before you put your strapping on.
Obviously, if it needs to be sealed and you got straps over top,
Yeah.
had to come
Yeah,
first. Yep.
you can't go over top of that. It's going to create a big hole for air and water
Yeah.
tightness. And so when you're installing the insulation here, you got to temporarily put it in place with long screws and big washers, or nails and
washers,
nails,
yeah.
washers, and some sort of temporary means so you can do all the detailing. Then you put your strapping on, and then you put your cladding on. Okay. So the air barrier strategy for this wall is the foam and the tape. The
water resistant barrier.
and the water resistant
Yeah.
barrier. And there really is no other option for the wall with the way we've detailed it in this guide. This is the air barrier system. Now, where you start to see the challenges with this are potentially at your roof to wall interface here. So we've got on the inside, we've got our air barrier at our ceiling, our polyethylene in this case with a vented attic. We got the air barrier out here, and we need to transfer the air barrier through the foam, through 2 layers of foam, and then back to the backup wall here. And so what we've shown is we're using a flashing tape to basically make this foam and this tape here airtight all the way to the backup wall. And then we're transferring the air barrier through with tape. You use the same tape even on the top plate, and then transferring through the air barrier through the wood framing to the inside of the wall here. And then we've got poly on the ceiling, but we don't have poly on the wall. And so to address potential leakage at the plate here, they've actually taped across the plate here.
Yep. Yeah. Again, 3-dimensional corners.
Yeah.
With the tape, if this went around a corner at the top of wall, you would have to treat across the corners.
That's right. Yeah. So the air barrier transfer, and so the tricky parts are just paying attention to where you're transferring away from the foam as the exterior barrier. Your window details, they're all done on the face. The flashing on the face here, you can see here with this flashing membrane, there's a taped on the top of it because it's not going to stick as well if we're not using this tape on the rough opening.
Yeah.
You can see one of the nice details down here is you got your ICF foundation concrete. Your peel and stick here is providing your waterproofing, but also an air barrier tie into that concrete, right? And so we've got the air barrier from the foam here transitioning into here and then back into here. Another way I've seen this done too is you put sealant in between those layers, but you have to seal around, and
Right.
you think of some of the picture framing you have to do.
The key is to think 3-dimensionally. You have to get it in every direction.
So this wall works really well. It works really well with more exterior insulation. So what I'm saying is the more exterior insulation you put on here, the warmer the backup wall becomes. And so ideally, actually, you would put potentially all of your insulation on the outside. You could even consider going back to a 2x4 wall here. And the reason you'd think about going to a 2x4 is you get higher ratio on the outside versus the inside. So if you're concerned about vapor control and dropping the poly on the inside, switch to a 2x4 with R12 or R14 bat instead of the R22 bat, and then put the 3-4 inches on the outside, and your ratio is greater than 50-50 or so. So the guide goes into more of the nuances of what you can do, but generally you're trying to get more and more insulation on the outside. So with exterior insulation, the challenges we run into are how to attach our cladding. Okay, we got 4 inches of foam here. We can't just nail the hardy, in this case, into the foam. We need to transfer the weight and the wind load from the cladding here through our strapping and then into our backup wall. Okay, so the approach, like the other exterior insulated walls in this series, is we're using long screws through insulation. There are other ways. You can use wood blocks, you can use clips, but if you're using foam as an air and water resistant barrier, it's really difficult to seal around ties and clips and other things, right? And so we're using this as our nice watertight and airtight face. And so we're going to screw through with just say intermittent fasteners through the insulation into the backup wall. And the way this approach works, and we've done a lot of testing to show structurally and from an airtightness standpoint and from a structural standpoint, these long screws through the vertical strapping create a truss.
Yes.
Right. You've got compression on your rigid insulation. You got tension in your fasteners, and that creates a nice truss. And then you nail your siding, whatever it is, onto the strapping here.
So I see you mentioned electrical boxes. That's 2 inches typically. We got two 2-inch layers of foam insulation. To install that electrical box to be flush with this, you would have to set up a receiver of some sort, maybe a backing plate on the first layer, and wrap it out the second layer to mount the box into. Just cut the hole so you can then screw to that backing plate, because I don't think you want to screw right through your whole wall for electrical. It's going to be what about future maintenance and all these other kind of things. So there's some things we could look at there, but I see that as doable for sure.
Yeah. One thing with foam insulation is you can cut it fairly easy with a knife, or even hot wire, to cut around penetrations.
Right.
So yeah, it's thinking about that. But then if this is your air and water resistant barrier, then you need to seal that box in to be part of that.
Yes, and that's where I was going to go next. So yeah, I cut a hole through here for my my box receptacle. I put some backing in there, but now I got to seal all that back through around through that electrical box, just like you would for your air barrier. So set it into caulkings or whatever may happen necessary.
Yeah. So, and the manufacturers of these insulation products have a lot of those details to start. The LEEP guides provide another layer of details to sort of expand this and push this all the way to the higher R values. This approach, using exterior rigid foam insulation has been very common across Canada for decades now. Just what's unique here is we're using more of it, and potentially 2 layers, which create some new challenges, but also some new opportunities for your details as well.
Yes, no, and I think the key there is to look at the details that are provided for the systems and understand them if you're going to endeavor in this kind of wall type.
Yeah. So in comparing and contrasting this wall assembly here, wall number 2, and we're going to talk about wall 3 in another video. Wall 3 moves the air and water resistant barrier behind the insulation. So the insulation's just insulation, like in wall 1. The unique difference with this wall here is the air and water resistant barriers on the surface.
Yes.
And it allows someone to see that and do it later on in the process. Do you see any constructability improvements with this?
Well, what I see is you need to do all the insulation, then the strapping, where sometimes a process can be expedited when it can be layered and sequentially staggered.
Yeah.
And so, like others that we'll talk about in upcoming videos, that when this is just the insulation, perhaps I could start the strapping at the same time. So it would be about getting these all these tapes and joints, everything in place.
Yeah.
And as with most wall types, it's not really a problem on building the wall types, okay? Because they're already done. The challenge is establishing a process with your guys and your build. Okay, your team is working for you and you're building this with a set process. I think, and what I see is when somebody first takes on a new wall type that they haven't done before and just starts to try to wing it, may not have a wonderful experience. I don't care what wall type you're talking about. When you do something new and different, you kind of really need a plan and a process. So I know this one is installed throughout Eastern Canada particularly, and it's been quite successful. But it is simply a process. And the part that is, from a constructability standpoint, is the degree of separation between the 2 layers, okay? Which you can work around. You get a wall at a time, make sure you make your corner transfers and all that, and then start. And you can stagger it, but that would be what you would want to figure out is how can you expeditiously execute this wall type, which does indeed work.
Yeah. Yeah, I mean, there's definitely some pros of doing all the detailing on the front here. It's different. This approach here, traditional wood frame construction, and shifting everything into the outside of a new material, right, with new tapes and proprietary materials, is certainly unique. As we'll show in wall 3, you can also take this approach of rigid insulation and just move everything in behind too. So if you don't want to use this approach, you can use the same insulation. You can move the air and water resistant barrier behind the insulation from a detailing standpoint, if that might help your process or constructability as well.
There's an advantage to moving it on, or having it on front side too, and that's review and repair during the course of construction.
Yeah.
It's readily visible. You see that it's sheared or damaged, you repair it.
Yeah.
As your claddings come up, pre-cladding review. Yeah, everything's inside. Go ahead and clad it up.
Yeah.
Even your cladders are savvy. If they see it, the repair is very simple. So there is an advantage to having an important layer as we move forward, where airtightness is going to be so prevalent in our world that you can actually see it. And if you manage your details, I believe it can be a really good air barrier.
Yeah, I've also seen this approach used without, if you don't need sheathing. Say you're using let-in strapping or cross bracing in a low seismic zone. If you don't have sheathing, you can use this as your rigid sheathing, right? And this was initially what it was intended for. So if you actually don't have a backup wall here too, that saves that material and that labor of installing that.
Yeah, and as long as you understand the nuances, as you put it,
Yep.
with the wall type and where you're building it, fantastic.
All right, so we're looking through a section of this wall assembly here. So we got our attic insulation, our attic air barrier, ceiling air barrier, I should say here. We're transitioning the air barrier through, down the face of the insulation, all the way down, and into our ICF. You notice one of the nice things about this assembly too is we don't have a vapor barrier on the inside. So we've got enough insulation on the outside that we don't need a vapor barrier on the inside. We actually don't want one. So what that means, you can just stuff the insulation in, and even at your rim joist, you can just stuff it right in there. You don't have to worry about sealing that up as well. And so that it can speed things up on the inside. You still have poly in the ceiling and other
And the
details.
drywallers won't have any polyethylene to cut to make the boards fit.
That's right.
That's fantastic.
So no poly, all exterior insulation. This is providing your air, vapor, and water control on the outside.
What about thermal bridging? I see we got a nice stagger here, but not so much here. I guess there's an option you could drop that down and...
Yeah. Yeah, the BCIT team, when they built this mock-up, they wanted to be able to take this roof off to fit in.
Well, sure, of course, I understand that, but it's still a point of discussion.
Yeah, and actually, you're going to end up with lots of situations where you don't want it. You don't have a stagger, but even doing a 1-inch stagger can go a long way. This insulation does expand and contract a bit with temperature, and the new formulations of rigid insulation don't shrink like they used to over time. So we're looking at this. It's going to stay roughly the same size forever, but there's going to be some expansion and contraction, which can move things around. And so staggering joints helps to reduce those gaps and also those thermal bridges through your insulation.
Is that a significant loss of thermal? Or?
If you have enough of them interconnected, if you have enough pathways, then you potentially could start losing.
A little bit of short circuit there?
Yeah. But generally with taping and sealing them, then you're going to be pretty good.
Okay.
So top strengths and weaknesses?
Inherently, it can be made simple. I'm going to answer on a 2-layer perspective, because the single layer, I think, is going to move more and more to the outside as we need to meet energy targets. Okay, so on a 2-layer and a staggered insulation approach, a lot of pieces can be trims and all that around windows, etc. Can be pre-made. You can pre-manufacture. What I really like, because I'm kind of an air barrier kind of guy, I like the fact that I can access my air barrier. Even when you put it on the backside and you put the straps in, everything from then is blind, even though everything attached then goes to the straps. Okay, but it's blind. Here it's on the front, so you can really do a nice review. Like, what kind of building are we doing here? Do we have a really complex structure and lots of ins and outs? It could start to be a bit challenging, where a flanking path could easily be overlooked. So I would really focus on review. It's simple.
Yeah, I think this wall can be very simple. The trick, and I think the better success, is going to be coming on actually using more insulation, dropping that vapor barrier on the inside, and not having these scenarios where you have a thin amount of insulation and having to deal with that vapor control.
Yeah, and I'll agree with that, because I find that when you have multiple layers of insulation, on the testing that I've done, I'm not able to get the water to the backup wall regardless. So your water penetration resistance, you stagger layers, inherently increases.
Yeah, and that's why we're relying on the face here. We don't want any water getting behind
No.
here, and that's important with this one. Is this is detailed? There's no backup. There's no redundancy in the backup wall like there is with some of the other walls. So you got to make sure it's perfect on the face.
So the concerns, the considerations, are not really concerns, is course construction moisture, and condensation and potential dryings.
Yeah.
And these are the nuances that
That's
are
right.
referred to in the guide, right?